Yes, welcome to the last session of the morning. I hope there's still some attendance before lunch. And hopefully I have some pictures that keep you aware of applications in the PV sector. And thanks a lot for inviting me to give you a short note about the company, of course, and also the PV applications we have done. I would like to talk a little bit about our vision because we follow the idea of a 100% renewable energy supply and the role PV will play in this supply system in the future. I will give you a short overview about different kinds of renewable energy. You have heard a lot of it just now about wind energy, but also in the morning about bioenergy, and I will focus a little bit on the energy mix. Then I will show you some applications, and finally I would like to draw the attention to the question, when will we get grid parity? When will be electricity produced by solar cheaper than the electricity we have right now from the conventional utility? So this is our vision, 100% renewable energies, and these are mainly the fields of our activities. So we started with wind energy 14 years ago, and are now focusing also a lot of PV systems, so solar energy for the electricity market. And then we have bioenergy, mainly in the kind of biogas, not for the transport or mobility sector, because there we focus much more on electric vehicles. And U is also geothermal and hydropower, as well as in our own research and development department. We are serving the whole value chain, like finding sites, buying components, realizing the project, later on selling the project to an investor, which might be a utility, which might be a private homeowner, which might be a large investment company from all over the world. And some of the turbines still stay within our company. And later on, for this owner of the power plant, we do the maintenance and the commercial as well as the technical operation issues. Some word about the UV Group, very shortly. We were founded in 1996 by two guys in Germany who have the same idea of installing a wind turbine, so they met each other, and right now we have more than 800 employees all over the world, and which is of course also a good sign for the development of renewable energies in general. And just to give you a figure, last year we received about 12,000 job applications. So it's much more than the conventional utilities received during a year. So the attractiveness of renewable energies is growing very, very fast, especially for young people. This is a very interesting area of working. You see we have 400 wind turbines all over the world. You see one large one here in Costa Rica. We just inaugurated in April this year. It's 55 turbines. It's a very, very windy site. It's from the company Enercon, which is the manufacturer of the turbines, and for them it's the most windiest site of the world they ever have worked on. And we have installed a lot of PV installations, like this one in eastern Germany. It's a free field installation on a military area, which has a capacity of 53 megawatts. So this is something like 53,000 households. And you see it's a typical size for a wind farm usually, but not for a PV installation. But of course, we have a lot of space available also for this large kind of PV installations. And this is where we are active. Our focus is Germany right now with wind, PV, and bioenergy. And the next large markets for us are right now the US, where we started the first wind farm project, but where we have also installed large PV systems, free field on the rooftop. And in Europe, it's mainly France and Italy. But we also have other kind of installations, like in Rwanda, it's a free field installation. And for Senegal, we will have an off-grid installation. I will come back to that later on. So just to give you a short overview about renewable energies, because I know you heard a lot of conventional energies yesterday, and you heard about some different kinds of renewables today. So the question always occurs, is there enough renewable energy available for the world market? And the answer is simply yes, it is. And you see here, you see here the annual world energy requirement, and you see the different kind of renewables, and by far the largest part of potential is given by solar energy. And this is also reflected by a new study just published last month by the European Renewable Energy Council. And I would like to draw your attention to two figures. You see the PV capacity is very low at the moment, so it's just 4.9 gigawatts, and compared to wind and hydro, it's a very low figure. But if you look in the future to the year 2050, you see the largest amount of renewable energy capacity will be given by PV, and then by wind, as we heard just before. And this is the consumption. So you see in 2050, most renewable energy will be produced by wind turbines, and the same amount probably by PV installations. Some general aspects to wind energy. I will not focus again on the figures, and fortunately are the same one because we have the same sources. So you see the three large markets at the moment, the US, Germany, and Spain. And you see that there is 160,000 megawatts installed, and the prospects of having 400,000 megawatts worldwide in the next 5 years. And as all kind of energies, there are pros and cons. And this, of course, is also available for renewable energies. So the big advantage of wind energy, we have right now low production costs because we have a very sophisticated technology right now, and we have a very high energy yield per area. So just to give you an idea, if you have a new wind turbine of the 6 megawatt class, which we in Germany are at the moment installing, you produce 20 million kilowatt hours on just one site. Just to keep the figure in mind, because I will come back to that later on. So 20 million kilowatt hour per site, per 1 hectare. And of course, of the negative aspects of wind energy, we mentioned that before, is the volatile production and the change of landscape, and it might be in times the birds and the avifauna and so on. Solar energy. You remember the figure for wind power? We had 160,000 megawatts installed wind power capacity. Now we have 20,000 in the PV market worldwide. By far the largest market at the moment is Germany, with nearly half of all the installations. And then we have Spain, Japan, the US, and Italy coming up in the next years. And the prospects is just 30,000 megawatts in the next 5 years, compared to the 500,000 megawatts we just have seen for wind. And you see here some kind of installations. This is again a picture of the large PV installation in eastern Germany. And this is a soccer stadium of Verona. We have built a similar installation in our home city of Mainz in Rhineland-Palatinate, a smaller one, but there will be a new soccer stadium next year, so we will get an even larger one than this one. The advantage of solar energy, of course, is again a quite high energy yield per area. It's not as high as it is in a wind power sector, but it's much higher than we compare that to the bioenergy sector. So for example, if you have 1 hectare and you put a free field installation on this hectare, you will harvest around 400,000 kilowatt hours a year. And if you do that by biogas plants or something like that, you have a factor of 10 less. And compared to a wind turbine, it's still a low figure because there we have 20 million kilowatt hours. We have, in general, a good correlation between the energy demand and the energy production of solar energy. So, for example, if it's very hot, you have a lot of demand for cooling systems, and a lot of demand for electricity, and then you have a high radiation, so you have a high energy production. And if we have, at the moment, quite high production costs for solar energy, and of course, also, this is volatile production. And some other renewables, just in general, not to go too much into detail with this. We have bioenergy, we have hydropower, geothermal energy, we have ocean energy like waves, and perhaps there is something new to come in the next years, who knows. And all of these have, of course, also advantages and disadvantages. We have a very stable production usually with this kind of energy. We have low production costs. More or less, hydropower is a very sophisticated and well-known technology. We can influence the correlation between production and consumption, because we can store, for example, the wood and decide the moment to burn it. But we have the low energy yield per area, and we have limited potential, sometimes for bioenergy, as we learned in the morning, and sometimes also for hydropower. So we are much in favor of the energy mix. It makes no sense to follow a 100% supply only by wind energy, as it makes no sense to follow a 100% supply only by solar energy. So the main focus is on the energy mix, and of course this should be 100% renewable. And I will show you later on a study we have performed for a federal state in Germany, where we made a distribution with this kind, and I will show you if there's enough space or not, for example, for PV installations. And just right now, to show you one site in Germany, it's the energy landscape in Moorbach. It's close to the city of Trier in the very southwest of Germany. And it was a former military US weapon depot, the largest in Western Europe. And then they converted it together with the community and together with us to an energy landscape. And right now, we have 14 wind turbines over there. We have several kind of free field installations, tracking system, like following the sun or not following the sun. We have a biogas power plant, and all the electricity goes to the grid. And the heat of the biogas power plant goes to a wood pellet production site, so where we dry the wood before we produce the pellets from it. And this is very attractive also for the community, and they are building right now a visitor center. But without doing any efforts to attract visitors, they have seen more than 20,000 people from all over the world try to find more about this energy landscape. So probably there will be much more visitors in the future when they do a right marketing for that. So the next step is some photovoltaic applications. How is a PV system working? I mean, this is quite basically the same case in all kind of PV installations. So you have the sunlight coming on the panel, and that some chemical processes convert the light into electricity. A lot of people think if there is no sunshine, there is no electricity production. Of course, that's wrong, because we use the light. So if there are clouds on the sky, or there is dust on the sky, there's still an electricity production in a solar installation. And then, depending on the application, usually you have some kind of inverter system that transforms the direct current into the current you need to feed it into the grid. Or you have some kind of battery storage system if you have an off-grid installations. And then there are at least 3 kind of applications: building integration PV systems, free field application systems, or off-grid systems. This is our headquarters in Wörstadt, close to the city of Frankfurt. And there we produce 2.5 times more solar energy than we need. And this is mainly done by several kind of PV installation, classically on the roof, of course, and then here on the facade, as well as in the window of the dining hall. So we produce electricity more or less at every corner. And another idea is to produce electricity on the parking place in front of us. So this is a carport, a traditional carport, so you can also use that without the panels, so it keeps the car dry, and what is more important, keeps it cold in the summertime, because if you have a black car, you feel very much the difference between having a carport or having not a carport. And this probably will be a basic element in the future supply system for mobility. So, for example, the German ministry has the idea of bringing 1 million electric cars into the market by 2020. And just yesterday there was a large presentation, and one of my boss was there to talk with the Chancellor, Mrs. Merkel, about these ideas and talking about different kind of questions. How can we supply the energy for what's this 1 million cars? And it's quite easy. And for example, to stay with the wind turbines, it means just 16 wind turbines each year. And so in 2020, we will have 160 new wind turbines, and that will produce enough electricity for 1 million electric cars. And the other idea is to use more of this kind, because we have a lot of space available. to use this, because mainly the car is not for driving. It stands most time of the day on a place. So why not charge it then during this time? And why not recharge it then later in the evening to supply your own home? So this is a system in the future. So electric mobility and solar energy or renewable energy in general will play an important role in a common energy system in general. Some other building integrated PV systems like soccer stadiums. This is the one in Mainz. And unfortunately, most of the stadiums were built according to architectural features, not so much to stable roofs. So there are not so much space available. And now here, for example, this is the south side. That's quite nice because it's inclined to the south and it's a flat roof. But here you have all this shadow throwing things on the roof, so it's not really available for PV systems. Then you have market halls or logistic centers or whatever. Nearly all roofs are available. Or very often it's the question of the owner of the hall. Is he in favor of solar energy and will he fit with you for 20 years? And the statics, of course. Then free field installations, which is an area we have focused within our company. This is a solar installation in Rwanda. We built 2006 together with the land of Rhineland-Palatinate because there's a friendship since 25 years right now. And this is mainly used to drive the water pumps in the area. It's close to the city of Kigali. Then, of course, Spain. Everybody expects Spain to have a lot of PV installations because of the sunshine. Then this is a German installation, also close to the city of Trier in the southwest. This is a large installation we are just now constructing on Corse, in Rapal, in the southwest of the island. The largest one for France, I think, at the moment. And then we have specialized a little bit on former military areas. So this is a former airfield in eastern Germany. And when we started this project, it was the largest one in the world. It was the beginning of 2007, sorry. And we were building this more or less 2 years. And when we have finished, there were 2 larger projects already grid connected in Spain. So now it's, I think, at number 10 or something like that. This is 2,000 meters. And this is 600 meters in wide. And we have built up an even larger one. And this is also a military training area from the Russian army. It has a total area of 28,000 hectares. And we are using just 200 hectares of this. So some might imagine there's much more space available for the PV system over there. Here we have a special deal with the ministry. Because there's a lot of pollution in the ground, because when the Russian army left the ground, they brought all together and they dig it, and now the soils and the chemicals, the fluids, they all go down to the groundwater, but they have no money to pay to get it out again. So by leasing the land to us, they get money to clean up the area again. So this is some kind of a pilot project also for this kind of PV installations. And finally, some off-grid installations, like for a hospital in Peru. Well, actually, it's also a free field installation, but a very small one. And a small rooftop installation. This mainly goes together with the storage system of batteries to provide constant energy. And we have that also incorporated in our company in Wörstadt, in our headquarters. We also have a storage system over there. I will come back to that later on. So on the way to grid parity, so as I mentioned before, solar energy is quite expensive right now. And you see here the feed-in tariffs for Germany for different kind of applications. So this was the feed-in tariff 2009. It was nearly 32 cents per kilowatt hour. The operator of the power plant gets from the grid operator. And this was reduced by 10% in the 1st of January. This is done every year. And this is fixed for 20 years. So you get 32 cents per kilowatt hour for 20 years when you install the plant in 2009. When you do it in 2010, this price is fixed for 20 years. If you do it in 2011, we get another reduction of more than 10% because there was a dramatic drop down in July this year. So we talk about 25% reduction to the beginning of 2011. And this is again then fixed for 20 years. And there are higher installation or feed-in tariffs for roof depending on the size of the roof. As you see here, the price for electricity for the end consumer right now is around 22 cents per kilowatt hour. So we are still a little bit away. So if we talk about 40 cents per kilowatt hour, or if we talk about 35 next year, something like that, then we still need some years to get a grid parity point where the electricity from your roof is cheaper than the electricity you buy from your supplier. But since traditional energy costs are rising because of the lack of resources in the future, then we say it's about 5 years. In 5 years, the electricity from your roof will be cheaper than the electricity you buy on the market as an end consumer. And then, of course, you have some building technologies where it might be make more sense to use the electricity right now. We, as I mentioned before, have PV systems on the facade, on the roof, on the carports. We have a storage technology, and we had a lot of energy-saving aspects in our building. And it's one of the most energy-efficient buildings of the world, office buildings in the world. Probably it's the most efficient one. And beside all the PV installations, we have this storage room, so we can be independent from the grid. Well, right now we feed the electricity into the grid, but if there is a lack of grid, a shortcut, then we can use our own system to supply ourselves more or less the whole time in summer and about 2 or 3 days in winter times. Because in winter you need more electricity usually and you have less sunshine, so the time to load the batteries is not so long. And you can really put PV installation nearly everywhere. So this is our dining hall, and we have integrated the cells into the window. And besides giving electricity, it gives you a shadow, so there's not so much heat in the building. And it, of course, is some nice aspects because it moves. Also in small installations, like in our kindergarten, there is a PV installation on the facade and also on the roof. And there's also a small wind turbine. So sometimes it's possible to build up a small wind turbine in your garden, but you have to be aware that it's very expensive because there's much proven technology in this kind of wind turbine we have just seen before, but there's not so much technology involved right now in this one. And we just calculated the time of reinvestment when the money coming back if you build this one and just feed it into the grid, and we came up to by 200 years. So even if you use it by your own, you say, okay, I don't get the 10 cent per kilowatt hour, I pay myself 20. It's just 100 years. So and the question of maintenance, of course, is also involved with this. But anyhow, it might be a nice architectural figure. And then another interesting question is large free field installation. How can they come to grid parity? Because if you see an airfield with solar panels, there is no home which could use the electricity directly. So we are talking about combined renewable power plants. So it gives you wind turbines, solar panel, bioenergy perhaps, and keep the money in the region instead of importing energy and exporting the money. So there might be a system of wind turbines combined with PV power systems, bioenergy, when there is available hydropower and geothermal energy, because this three is nearly everywhere available, more or less. But this too needs some more natural research. And the advantages are quite quite clear, and I mentioned it before by the energy landscape in Morbach. So it could secure a purely clean energy supply, and we are proving this already. So we sell some of the electricity we produce by our own in Wörstadt with 5 wind turbines. We sell that directly to the community, and it's cheaper than the conventional energy they get offered. So there's a special program right now going on. And this is in the main components of this kind of power plant will be a large part of wind energy because it's the cheapest one right now. We will use large PV power systems because it's a good complementary energy source for wind power. Usually you have wind power in the winter time and sometime of spring and the autumn, and you have solar power in the summertime. So it's a very good combination of these 2 sources of energy. And then we use the flexibility of bioenergy for the lag when there is, for example, it's night and no wind. Of course, you need energy. And then it is done with bioenergy because you can store the biomass, for example, quite well. If you think of wood system, for example, you can decide yourself, when do I burn the wood for producing energy? And I do not have to do that when there is a lot of wind or when there is a lot of sunshine. I can do that when there is no wind and no sunshine. And of course, I can work on the other side of the system. I can regulate also or applicate the demand of energy by using light efficient systems and so on. And just to give you an idea, we made an example, and we are offering this in Germany to industrial clients like automobile manufacturers and some other kind of industries. They are very, very interested in renewable energy power plants, very close to their site perhaps also, because all of them on the one hand would like to have a clean image. So producing clean cars with clean energy, for example, quite sure. So if you see the price for this kind of combined renewable power plant for 2013, we calculate a combined energy mix price of 11 to 12 cents per kilowatt hour, and this is somehow comparable to the price large consumers pay right now. And the question always connected to PV installation, will there be enough space for all this kind of energy? Do we need 3 times Spain to supply some part of German PV's electricity? And we made a calculation for our home state of Rhineland-Palatinate. Here is the city of Mainz. Wörstadt, where we are located, is somewhere here. And we built up a scenario for 100% renewables by the year 2030. Right now we are somewhere by 30%. And we have a large share of wind power, and we have equal shares of solar, bio, and geothermal power, and a little bit hydropower. And geothermal is a big question in all of this because there's no geothermal power plant in a larger dimension working for several years right now. We have a small one here in the south of Rhineland-Palatinate with a capacity of 3 megawatts, but it's still in the kind of testing operation. So 15 to 20% solar power, what does that mean? And when we say, okay, in the middle is 17.5% of solar power, that means something like 4,500 megawatts of PV. And if we put that on an equal share on private homes, like this one, on industrial roofs or on free field installations, we need this space. So the sum of this is 9,200 hectares. And it's just 3% of the area we right now use for settlement and traffic. So it's quite low figures. And to give you an idea what this means for wind turbine, 40% wind turbines. So if we use the newest applications, the 6 megawatt turbine, we just need 500 wind turbines to produce 40% of the power of Rhineland-Palatinate. And the space for 500 wind turbines of this class, if you put them in a wind farm, for example, it's just 0.2% of the agricultural area and 0.2% of the forest area. So very, very low values. When we talk about bioenergy, it's a little bit more complicated. But I think we learned much more about that in the morning. So this is what I would like to show you about the kind of PV applications. I'm open for questions right now, and thanks for your attention.